Hello again, everyone. Welcome back. This will be the solutions to the second set of questions or math problems for the electricity unit. So we're looking at this one here. Okay. I hope you've given it a good effort. Again, it goes without saying, you should always have your cheat sheet with you, and it should be full of all the information you need to do this. Okay. So our first question says, what amount of charge? So we're looking for charge, and we're given 3 amps and 1.3 hours. The first thing that jumps out at me is that 1.3 hours has to be converted into seconds, and you would multiply it by 60 and then by 60 again, and you should get 2,340 seconds. Okay, and then we're going to go look for our equation that deals with charge, amps, and time, and we're going to manipulate it so we can figure out charge, and we're going to see that charge is current times time. We're given 3 amps, and we have our time of 2,340 seconds. In my notes here, I'm getting different numbers for time here, so that may be the wrong time. If you have a different time, you're going to have a different answer. Final answer is 14,040 coulombs. Okay. If the time is off, I suppose I could check that really quickly if I had a calculator, but I don't, so let's not worry about it. If your time is different, you're obviously going to have a different final answer. Maybe we can discuss that in the group chat. Okay, just make sure we have the right answer. Number 2, we have what current symbol is I, does a stereo receiver draw if it's used for 2 minutes? Let's immediately make that 120 seconds. How's that? If it's used for 2 minutes and goes through 10 coulombs of charge. So 10 is our Q. Find the right equation, manipulate it, so I equals Q over T equals 10 over 120 equals 0.083 amps. Number 3, how long? So a time question. How long can a flashlight run if it draws 0.11 amps? The current for amps is I don't want to confuse you guys. And the battery contains 10 coulombs of charge. So we're going to go find our equation that works, okay, that involves those variables, and we're going to manipulate it so that it's time equals Q over I. And we've got our Q, which is 10. We've got our I, or our current, which is 0.11. And that's going to give us 90.9 seconds. Number 4. We're given 25 ohms and a voltage drop of 12 volts. Calculate the current. We love these ones, right? Because it's classic Ohm's law that involve the relationships between voltage, current, and resistance. So we find that triangle rather easily, and we manipulate it for current equals voltage over resistance. 12 divided by 25, so that's going to be right around a half, which calculates out to 0.48 amps. Number 5. Number 5. We're given 35 amps flowing through Vili's iPod Nano. I think I made this question a few years ago. with a resistance of 120 ohms. Calculate the voltage. Voltage, current, and resistance. Again, this is Ohm's law. Maybe we'll go back real quick. I know I'm skimming over these triangles all the time with you guys. Okay, so if we go back to the resistance, voltage, current triangle, just to make sure you guys are kind of thinking like this, even though I just skim over it all the time. When you've identified the three variables we're talking about, you got to find the triangle that has all three. And then when you want to figure out one of them, you cover it up and you kind of do the operation that's left, which would be resistance times current, right? If I wanted to find resistance and I was given those two, it would be voltage divided by current, okay? I hope everybody's with me on that. So voltage equals resistance times current, 120 ohms times 35 amps, and that gives us 4,200 volts. Okay, one last question. Now, if I'm not mistaken, this is a two-parter, mainly because it's such a long one. A pitching machine is so powerful that Duncan always strikes out. Once he fouled off a pitch. It runs on a voltage of 100 and uses 10,000 joules of energy. Determine the current that flows through this machine in 2 minutes. I'm immediately making that 120 seconds. Determine the current flowing through this machine in the 2 minutes it takes Duncan, and the rest of his classmates for that matter, to strike out. Okay, so what we're going to do is we're going to figure out, well, we need our current equation for sure. So we need I equals Q over T. The problem is we don't have Q out of this information, do we? We've got the T, but we don't have the Q. So we need to find a charge equation where the information's there to let us have it, okay? And we know that charge is our energy divided by our voltage. Joules divided by voltage. So 10,000 divided by 100. That's an easy one. That's 100 coulombs. Now we can take that and throw it in there, right? So moving this way now, we've got our 100 over our 120. Sorry, I'm running out of room here. We know that's a little less than 1. In fact, it's 0.83 amps. Okay, so that's your final answer. I hope all that makes sense, guys. If you have questions, please email me.